Hey, here we go. I want to talk to you about three-dimensional matrices and the solving them. And I told you we'd take a look at a plotter, all right? And our next chapter problem, which I want to give you probably tomorrow, is going to have you use a three-dimensional plotter to solve what we call a system of inequalities, but in three dimensions. So we'll start talking about that a little bit more on Thursday, about systems of inequalities. You did some of that last year, but we're going to do it this year, but with three dimensions. So we need to take a look at a plotter and get an idea of what's going on with the matrices part. So let's go ahead and do that. All right. First of all, you're going to need to log on and open up a couple different browsers we can use. Okay. One of them is a CPM. Okay, application that's a 3D plotter. And the other one is one we've been using for a few years, Monroe CC. All right, Monroe Community College. They wrote the application that does it. It's also a 3D plotter. All right, and either one of them are pretty good. I'll show you both of them, and I think I'm going to use the Monroe just because that's the one that we've been using so much. So you can use those two. GeoGebra also has a 3D plotter, and it's not too bad, although I kind of like these ones better. But let me show you first of all both of them. But let's start off with an example of a system of a 3x3 system here. Okay. 3x plus 2y minus z equals 6, and negative 2x plus 2y plus z equals 3, and x plus y plus z equals 4. Okay, so we're going to solve this. All right, and you might remember to do that, we're going to write a matrix equation for it. All right, like this. And then what we want to do is use our matrix calc, right? The application that we found. So we should have that available. So we're going to go to matrix calc. There it is. Okay, so then I'm going to take and put those numbers in. All right, so I'm going to go 3 and 2. Negative 2. And the last one, a bunch of 1s. Okay, then I'm going to come over to B, put those in. All right. Okay, so then what I want to do, remember, is take the inverse of this matrix and multiply by that, but I have to do it the correct way, right? So I'm going to find the inverse of this. All right, I'm going to insert it in A, and then I'm going to take A times B. All right, so there's 1, 2, 1. So that's my solution. All right, works out fine. So let me write this out. 1, 2, 1. All right. But what does that really look like? All right, in a graphing sense, because when we had the 2x2s, we could graph those, right, and find an answer. But what about these? All right, so let's go into this, and let's take a look at the CPM here. So let's try. What we want to do is go to technology. Oops, I'm messing up here. TECLOGY dot CPM and .org, and I want to see if I can get something out of that. And let's see what I'm looking for. I'm looking for 3D surface plotter. Let's see if that's in there. Yeah, maybe I should back up a little bit. Put in after this. Let's go with technology. .cpm.org/ let's go general / 3D graph. Let's see what that does. Okay, so there it is. So there's my 3D plotter. All right, notice we have an X, Y, and Z axis. All right, so you should have had some of this last year in geometry where you talked about the x-axis kind of coming out at you, y-axis going sort of horizontally across the screen, and the z-axis going vertical. All right, so we want to type in our equations. Okay, so I want to go here, tap on that. It says x plus y equals z. So I'm going to go and see, well, what were my equations? My first one was 3x plus 2y minus z equals 6. So what I'm going to do is go to this plus here. Oops, sorry, back up. We don't want that one. I'm going to go to this and tap right there, okay? And I can add my A, B, C, and D. So it's AX, BY, and CZ. So I just change this by getting the equation that I want. There's 3x plus 2y. Oops, I want minus. So there's a -1, and then I want this to be 6. So there's my equation, 3x plus 2y minus z equals 6. And what I get is I get this plane, right? Because in 3 dimensions, when you have an x, y, and z, all those points represent a plane. In 2 dimensions, of course, it's a line, but in 3 dimensions, we have a plane. So now I'm going to come down here and get my next one, all right? I just hit plus right there, and it gives me another equation. This time I want to add more, so I need this to be a -2 for my x value, and a 2 for my y value, and a 1 for my z, and a 3 for the constant. So I have -2x plus 2y plus z equals 3. All right, now all I see is a line there. Wait a minute, I thought you said, oh, there we go. So if we touch this and move it around, right, we're going to get this 3-dimensional view of these 2 planes. All right, now hopefully this works on your mobile device, or on the Chromebooks. It should work okay. It might even work on your smartphones. You can check it out at some time, but I wanted to give you the computer so that you could kind of play with it a little bit. All right, by moving it around with your mouse probably, or with the touchpad anyway, you should be able to move it around. Okay, we got one more equation we want to put in there. Let's see, we want x plus y plus z, and this just needs to be a 4. All right, so then if we look at these, okay, it's kind of hard to see, but at some point, they're all going to meet. All right, so I can see that it looks as if they meet all right there. If I zoom in a little bit, maybe. Okay, I can kind of see where they all 3 meet. It looks like there's a point right there. So what should that point be? It doesn't give it to me. I can't tap on it, right? It's not giving it to me. But if I zoom in enough, I can just about see it. Maybe it's as much as it's going to zoom. That they all 3 meet at this point that's just kind of sitting out there in space. All right? And that point better be 1, 2, 1. Okay, so there'd be 1 on the x, 2 on the y, and 1 on the z. So if I look, here's x coming out at me. So 1, 2 on the y, and 1 on the z. So that's pretty close to what it looks like it is. All right. So it'd be 1 on the x, 2 on the y, and 1 up. And it looks like they all kind of meet there. It's hard to tell, but it looks like they might all meet there. You can kind of see that point maybe right there. So that's the CPM plotter. It's a nice, again, it's pretty nice. It's not quite, maybe you got to hit it and tap it and put the pluses and minuses and so forth. You're not really entering the equations, you're just setting the coefficients, but it does work pretty nice. So let's try the Monroe one. So I'm going to open this tab up and let's see. For this one, we're going to go to Monroe cc.edu / faculty / I gotta put this guy's name in here. / You might want to know, well, doesn't Desmos have it? That they don't. They don't have a 3D plotter, but I wish they did. So it's called CalPlot 3D. We probably could have just searched for that. All right. Can't be reserved. Can't. Why? What's the problem here? Let me try this. If we can just do CalPlot 3D. If we can just, get it that way. There it is, right there. That is a much easier way to do it. Okay, so then we get a 3D plotter, and looking at that, you're going, wow, that thing's kind of cool. And we'll do some three-dimensional stuff a little bit later in second semester, but that'll be a little more interesting than what we're doing now. Well, let's go ahead and we're going to clear that out. And I'm going to add to the graph a function. With these ones, what I have to do is solve them for z. Okay, notice it says z equals, so I have to solve them for z. So then I'm going to take and do this, solve it for z. All right. So I'll go back to here, for example, and let's move this up here a little bit. Solve for z, this guy would be 6, z equals 6 minus 3x minus 2y. Now that would be a negative z, so I'm going to just change the signs on this. Okay, this one here is going to be 3 plus 2x minus 2y, and this one's going to be z equals 4 minus x minus y. All right, so we're just kind of rearranging the terms there, solving for z. All right, so then I'm going to type those in. So let's see, I'm going to go -6, all right, minus 3x, but it was actually a plus 3x. I'm going to go plus 3x. And let's see, I'm minus 2y. All right, so that's in there. All right, so I'm going to add to the graph here. I'm going to graph it. There it is. You can see this one's probably a little different to use. Now I'm going to select another function. All right. Delete those ones. I don't want that one. So this one here I'm solving. So I have 3 plus 2x minus 2y. Okay, so z equals that. Now I have that graph on there. There we go. Hope I did this one correctly, double checking that. Let's see, so maybe it's a minus 2y, and I shouldn't. There we go. Okay, so now I'm going to get another one. Put that one in. So I'm solving this one. This one was a little bit easier. So it's 4 minus x minus y. All right, tap on that. Okay. So now I have these, and you can see again that they're all going to cross. Okay, the only thing with this window, it's harder to adjust, I found out, than it is the other one, but you can kind of see it still pretty well. That they're all three going to combine. Okay. At one point. I'm trying to get it to stop. There we go. So two on the, I think it was 2 on the X, 1 on the Z. It's a little bit, it looks like it's right about there where they meet, and 2 on the Y. I think, what was it? Let's see. We had 1, 2, 1. 1 on the X, 2 on the Y. So let's see if we can get that. 1 on the X, that's coming out at me. 2 on the Y, going this way, and 1 on a Z. So it's right about there, someplace where they all meet. If we look, get a peek inside. So it's right around in there. So it's kind of close. All right. Again, it's really hard to see it where they meet, but you kind of get a feeling for that. Oh, it looks like they're all crossing right there. Okay. All right. So there's some 3D plotters that we can look at things. Again, it doesn't, you got to kind of pick your own, which one you like the best and use it. So let's go back and look at a different one, right? So let's look at one that doesn't work very well. Okay, so let's say we have one like this. Oops. 2x plus y minus 3z equals 0, and 4x plus 2y minus 6z equals 0, and x minus y plus z equals 0. Alright, so you got all of them equal to 0, right? So you know this isn't going to work. Alright, so let's see what happens. So we're going to write a matrix equation for this. 2, 1, negative 3, 4, 2, negative 6, 1, negative 1, 1. Alright, x, y, z equals 0, 0, 0. Alright, so we're going to type this in. I'm going to make sure I got it right. Okay, this time we're going to go into the matrix calculator. I'm going to clean that out. Alright, start here. So let's go to, and type this guy in. Pause this at any time you need to. Okay, so I got that in there. 2, 1, negative 3, 4, 2, negative 6, 1, negative 1, and 0, 0, 0 on that side. So remember, we're going to find the inverse here. Determinant is 0, the matrix is not invertible. Oh, well, that's what we had before, right? Remember on Friday, we had one, or Thursday, I guess it was, we had a situation where, hey, the matrix was not invertible. Okay, well, what's going on with it? We had to use elimination, figure it out. Well, let's go to the 3D. Let's do this one, I guess. That's what I said I was going to do. All right, so I'm going to kind of close these out here. All right, get rid of them because I don't need them. All right, get another one here. Okay, type this one in. I'm using the Monroe one. All right, CalPlot 3D. Get a view, see what's going on. All right, so I have two. Oops, I got to solve for z first. All right, dang it, forgot that. So how do I do this one for z? Well, we're going to have a negative 2x, right? A minus y. We have a 0 here. I put that there just for kicks there. I'm going to put a parenthesis around it, divide it by negative 3. Okay, so z is equal to that. All right, and then for this one, okay, same thing, 0 minus 4x minus 2y, parentheses, divide by negative 6. And here, 0 again, minus x plus y. I don't really need to put parentheses around that one, right? Because I'm just dividing by 1. So there's my 3 equations. I'm going to double check, make sure they're right, because if I make a mistake, it's going to look nasty. So let's go ahead and type these in. All right, so let's see. We got parentheses. I'm not going to put the 0 in because there's no reason for it. Negative 2x, right, minus y divided by, that's a slash, negative 3. Okay, so I put that in there. All right, now I'm going to go down to here, tap on that. There it is. Give me a new one. Thank you. Here we go. Delete this stuff out of there. Let's go with parentheses. I got a negative 4x. I have a minus 2y. And divided by negative 6. There's that one. Okay. And what? Well, I'll just leave it like that. So then we're going to go down here. Oops, I just got rid of the other one. Dang it. I'm right over the top of that. So now I got to go back through. Negative 2x minus y divided by negative 3. Okay, so now I got both of those in. All right, I need to add one more. Okay, so I can only see 2, but we know there's got to be another one someplace, so there's something going on here. All right, let's try this one. Okay, so we put this one in, which is negative x plus y. All right, because they're all equaling 0, so I'm going to put that in there. And let's see if I got that right. Negative x plus y, that's right. And I have this. So I'm wondering, well, where is the other one at? Okay, because I can only see 2 here. How come I'm not seeing the next one? Let's turn this one off for a second. Okay, so then when I graph, I just don't know where that one is, right? Maybe I need to zoom out. So let me zoom out. I'm out to 32. You might have said nothing changed, but look at the axes did actually change. Those numbers on the edge are changing. All right, I still never saw the other one. What happens if I kick that one out? Kick this one back in. Wait a second. Aha, 2 of those are the same. All right, and then the purple one comes down here. All right, and with this line here where they intersect. All right, so we can see that in this case, 2 planes are the same, and then this other one intersects it at a line, which gives us a whole bunch of solutions on that line. So we would have to come up with that line. When we did a problem like this on Thursday, you might remember that we did some elimination, right? We got down to a line because we cancel out one of the variables. Well, that's the line that gives you the solution. So that's what's happening here. All right, so when you're getting that line, the 2x plus whatever y I think it was or something, that's the line you're getting. This is what it looks like visually. Okay, so kind of neat. All right, let's go down and do one more example here. X minus 3y plus z equals 4, negative x plus 2y minus 5z equals 3, and 5x plus, minus 13y plus 13z equals 8. So now what we're going to do is do this one, okay? So maybe we try using the CPM on this. But we'll do this first. Write a matrix equation. See what it looks like. X, Y, Z. 4, 3, 8. Make sure I got everything right here. See, 1, 3, 1, negative 1, 2, negative 5, 5, negative 13, 13, 4, 3, 8. All right, let's do it. So why don't you guys go ahead and type that in to the matrix calculator. Let me know what you get. Okay, so again, matrix is probably invertible, right? Doesn't work. Okay. Well, what are we going to do now? So we go into our plotter, right? This time I'm going to use the CPM one just for something different. Get rid of that, get rid of that, get rid of that. Okay, I'm going to add one here, X, Y, Z, but I want to change it, right? So I'm going to tap there, and my A value in this case is 1. My B value is negative 3. My Z is 1. I got that one, and my D is 4. So there's that one, okay? Now I'm going to add one more. This time, let's see, I want negative X for that one. And I need a 2 for the Y. Oops. And I need a negative 5 for the Z. And I need my constant to be a 3. So there's that. All right, so we have, let's see, X minus 3 so far. Negative X plus 2Y minus 5Z equals 3. This is kind of nice because it shows you the equations. We want one more. Tap on that. We want 5 x's. 1, 2, 3, 4, 5 x's. A negative 13. There we go. And a positive 13 for this. And then the y has to be 8. All right, so now we're going to take a look at this graph. All right, and here it looks like there's some sort of intersection going on there. All right, it could be another line again, right? Make sure I got these correct. But in reality, what we should get here is no solution. So I'm wondering if something went wrong with it, if I did this right. If we work this out, this one should have no solution. And it's hard to see it with the graph on this. Right, but if we did elimination on here, you would find out that it doesn't work. Okay, there just is no solution to these. So if all three of these planes were parallel, it would probably be a lot more easier to see it. Okay, but in this case, we're not seeing it very well. All right. So it could be possible these three planes just don't cross. All right, but in a common spot. Remember, that's what we're looking for. They all have to meet in a common spot. And if they don't, then it would be no solution, which is probably what's happening on these. Okay, maybe we can zoom in a little bit. Or zoom in, I mean. Get a better view. It just doesn't look like they do. Down here, it looks like they're kind of meeting, but you can see that little triangle there showing that they're not. Okay. So, even here, it doesn't look like they are. They're just not meeting. That gives you an idea anyway of what's going on, which is what I wanted to show you. So when we get a matrix these that are invertible, we just don't say, oh, they're invertible. All right, and we're just going to stop there. We need to figure out, well, really what's going on. And that's why you should perform the elimination on it like we did to check and see if what the situation is. All right, so if we did do the elimination on this one, all right, and we just went 1, 2, 3, and we said, okay, let's do 1 and 2, right? So I'm going to go x minus 3y plus z equals 4, and negative x plus 2y minus 5z equals 3, right? And I'm just going to add these equations, so I get a negative y, I get a negative 4z equals 7, all right? Now I got to pick two more equations to deal with. Let's go with 1 and 3. I like those ones. And I have to remember that I have to eliminate the same thing. So I've got to eliminate x. So I'll multiply this one by 5, negative. So that gives me negative 5 plus 15, negative 5, negative 20. So the 5's go away. I'm going to get a 2y there. I'm going to get a 8z there. And a negative 12 there. So now if I take these two equations and I multiply this one by 2, okay, and I eliminate these by adding them, I'm going to get 16. That should not happen. I'm looking to see if I made a mistake. I'm up here, negative y minus 4z equals 7. I just added those. And here we want to cross negative 5, 3, z, 4. So that'd be negative, positive, negative 4, 5, negative 13, 13. So it should work out. We should get 0 x's, 2 y's, 8 z's equals negative 12. And multiplying by 2. Oh, we got to multiply by negative 2. There we go. So that makes that a positive 2y, a negative 8z, plus 12. Oops. No. Botching this whole thing up. That was from up there. So I'm multiplying this. So yeah, so I'm going to get negative here. So I'm going to get 2y minus 8z equals negative 14. So now when I add these, I get 0 equals 0. So it shows that they should intersect. This somehow should come out to be a number. I'm not exactly sure where my mistake is. Somewhere in this doggone thing, I got a mistake. But, so this should have come out to be like a 2 or something, and that would have messed everything up because I'm getting 0 equals 2, and that means we're getting parallel lines, okay? Sorry, I don't know where the mistake is, but that's what should happen, okay? I just basically wanted to show you what's going on with matrices and when they're invertible and what those systems look like graphically, and to see what it looks like using the plotters. So hopefully got some good stuff out of that. You had some fun with the 3D plotters, and we'll see you tomorrow.